This is lesson 8-1, video 5, and we're going to be applying what we just learned. And we are getting closer, much closer to the end of this lesson, so bear with me. This last couple of things that we need to cover are super important. But here we're going to be solving for side lengths in right triangles. So the problem asks us to find x, y, and z. Let's come over here and look at x, y, and z. We have x, which is our altitude. We have our big triangle, our medium-sized triangle, and our tiny triangle. And we're given a little bit of information. We're given the two segments of the hypotenuse. So let's start by solving for x. That's going to be the simplest place to start here. Of course, as always, we want to start with what we have enough information to solve. So let's say x squared is equal to 2 times 10. So here what I did is I said the altitude is equal to the two segments multiplied together. Let's go back one page and review that really quickly. I'm trying to think where we saw that. Here we go. It's the first corollary. The length of the altitude to the hypotenuse is the geometric mean of the lengths of the two segments multiplied together. So again, we're saying the altitude squared is equal to 2 times 10. So we have x squared equals 20, or x equals the square root of 20, which equals, let's see, the square root of 4 times 5, so that would be 2 radical 5. So we have x is equal to 2 square root of 5, or 2 radical 5. So now we have solved for x, 2 radical 5. Now we need to solve for y and z. These go back to the second corollary, where this time the length of a leg of the right triangle is the geometric mean of the lengths of the whole length of the hypotenuse and the segment of the hypotenuse that is adjacent to that leg. So this time we're going to be solving it a little bit differently. Let's start with y. We can say y squared, that's our longer leg, and we're going to multiply the segment of the hypotenuse that's adjacent to it times the whole hypotenuse, which is 10 plus 2, or 12. So this time we're going to have y squared equals 120. Y equals the square root of 120. And just to give you a quick review, that's also going to be the square root of 12 times 10. And let's see, that would be a 4 times a 3 times 10. So that's going to be, is that going to be 2 radical 30? Yes. So y equals 2 radical 30. Okay, so we have our y, and we would solve our z similarly to this, except for that time we will use the segment of the hypotenuse that's adjacent to z. I'm going to try to write in the edge of the book right here in a way that you can see. Z squared is going to equal 2 times, now again, 10 is not the whole hypotenuse, so we have to add that, 12. 2 times 12. So we multiplied the segment of the hypotenuse that was adjacent to the leg that we're solving for, and we multiplied that segment by the length of the whole hypotenuse, which is what our corollary told us to do. So we have z squared is equal to 24, and z is equal to 2 radical 6. All right, so just reminding you, the corollary tells us that z is the, let's go back and look at it, that z is the geometric mean of the lengths of the hypotenuse and the segment of the hypotenuse that's adjacent to that leg. So we also could have written this, and we could have done y the same way here. We could have written this as 2 over z equals z over 10. And that would have been the same thing. Z squared is equal to 20. Oh, I'm sorry. I hope you see my mistake. I hope you caught it before I did. It's not 10. That's not the length of the whole hypotenuse. It's 12. So in this case, z squared would equal 24, which is what we got right there. All right, so we have 2 examples that we can look at, and I'm going to turn on the overhead light really quickly. Bear with me just a second. I'm hoping that will make it easier for y'all to see. Okay, we're going to do the same thing here. We're going to solve for u, v, and w. So, as you can see, I have already done that. And what did I start with? Let's see. I started by solving for u, probably, because I knew that 9 squared would equal u times 3. So let's find that. I'm solving for u, and I said u would equal 9 squared would equal 3u. 9 squared is 81, equals 3u. 81 divided by 3 is 27, so u equals 27. Now, as you might recall, 9 is the geometric mean of those 2 segments that the altitude creates. So that would have been like saying 3 is to 9 as 9 is to u. 9 times 9 would have been 81. 3 times u would have been 3u. Okay, that looks like a W. Let me adjust that. All right, next we can solve for V. Now, I didn't really cheat, but I used the Pythagorean theorem on this because that was just quick and easy. So I said a squared plus b squared equals c squared in this right triangle, and that allowed me to solve for v, which was 3 radical 10. The other way that we could have solved for v was to say v squared equals the segment of the hypotenuse right next to it times the whole hypotenuse, which is 30. V squared equals 90, and v equals the square root of 90, which is 9 times 10, which is going to be 3 radical 10, just like we solved with the Pythagorean theorem. And lastly, we're going to solve for w like we did right here, but this time we're going to use the part of the hypotenuse that's closest or adjacent to w. So we're going to have w squared equals 27 times the whole hypotenuse, which is 27 plus 3, or 30. W squared equals 810, and w equals 9 square root of 10. Now, I know that this information is somewhat outside the box of things that we've learned and studied, but remember, keep going back to the corollaries that we learned on the previous page and the theorem that we learned on the previous 2 pages, and that's going to help you keep all of this straight. All of this is dealing with the geometric means. So what we did with w was we simply said w is the geometric means, or geometric mean, I need to stop making that plural, of 27 and 27 plus 3, which is 30. So you're given those relationships in the corollary, and then you simply solve, and if you look at this, you'll see it's exactly what we said here. W squared equals 27 times 30. All right, we have 1 problem left to do, actually 2, 1 example and 1 check it out, and that will be our last video.